Good morning, student. Today I am going to start new chapter, chapter 13, exponents and powers. Exponents. Exponents are used to express the large number in shorter form to make them easier to read, understand and compare. We can write large number in a short form using exponents. For example, 10,000 is equal to 10 into 10 into 10 into 10 means 10 raised to the power of 4 or simply as the fourth power of 10. 10 is called the base and 4 the exponents. 10 raised to the power 4 is called the exponential form of 10,000. Law of exponents. Multiplying powers with the same base if a is any non-zero integer and whole numbers are m and n, then a raised to the power m into a raised to the power n is equal to a raised to the power m plus n. For example, if 2 raised to the power 3 into 2 raised to the power 4 is equal to 2 raised to the power 3 plus 4 is equal to 2 raised to the power 7 means 128. Dividing powers with the same base if a is any non-zero integer and m n are the whole numbers, then a raised to the power m divided by a raised to the power n is equal to a raised to the power m minus n. Example, 2 raised to the power 4 divided by 2 raised to the power 2 is equal to 2 raised to the power 4 minus 2 is equal to 2 raised to the power 2. Okay. Next, taking power of a power if a is any non-zero integers and m n are whole numbers. So a raised to the power m to the power n is equal to a raised to the power m into n. Examples, 3 raised to the power 2 to the power 4 is equal to 3 raised to the power 2 into 4 is equal to 3 raised to the power 8. Next law, the law of multiplication of powers with different bases but same exponents. The general form of the rule is a raised to the power m into b raised to the power m is equal to ab whole power of m or a into b whole power of m. Example, 4 raised to the power 3 into 2 raised to the power 3. We can write it 4 into 4 into 4 and 2 into 2 into 2. We can write it 4 into 2 into 4 into 2 into 4 into 2. We have three groups. We can write it 8 into 8 into 8, 8 raised to the power 3. Now, we take second example, 2 raised to the power 3 into a raised to the power 3. You can write it also 2a whole power of 3. Okay. Next, numbers with exponent 0. If a be any non-zero integer, then a raised to the power 0 is equal to 1. 2 raised to the power 5 upon 2 raised to the power 5 is equal to 2 raised to the power 5 minus 5 is equal to 2 raised to the power 0 is equal to 1. So, we can say that any number except 0 raised to the power or exponent 0 is always 1. Now, numbers with negative exponent, if a is any non-zero integer, then a raised to the power minus 1 is equal to 1 upon a, or a raised to the power minus 1 is equal to 1 upon a raised to the power 1. Example, 2 raised to the power minus 5 is equal to 1 upon 2 raised to the power 5. Now, we revise the law of exponent. Insert a x to the power m into x to the power n is equal to x to the power m plus n. B, x to the power m divided by x to the power n is equal to x to the power m minus n. C, x to the power m into b to the power m is equal to x into b whole power of m. D, if x to the power 0 is equal to 1. E, x to the power m upon y to the power m, we can write it x upon y whole power of m. F, x upon y to the power n, we can write it y upon x to the power minus n. G, 1 upon x is equal to x to the power minus 1 or x to the power minus 1 is equal to 1 upon x. Now, decimal number system. In decimal number system, the exponents of 10 start from a maximum value and go on decreasing from the left to right up to 0. 45,672 is equal to 4 into 10,000 plus 5 into 1000 plus 6 into 100 plus 7 into 10 plus 2 into 1 is equal to 4 into 10 raised to the power 4 plus 5 into 10 raised to the power 3 plus 6 into 10 square plus 7 into 10 to the power 1 plus 2 into 10 to the power 0. It is called expanded form of a number. You have already learned the expanded form of a number in your previous classes. Expressing large numbers in the standard form. A number is said to be in the standard form if it is expressed as the product of a number between 1 and 10 and the integral power of 10. We can write this number 1.496 into 10 to the power 11. Decimal should always put after one digit. Observe the following. 59 is equal to 5.9 into 10. We can write it 5.9 into 10 to the power 1. 590 is equal to 5.9 into 100. We can write it 5.9 into 10 to the power 2. 5900 is equal to 5.9 into 1000. We can write it 5.9 into 10 to the power 3. 59,000 is equal to 5.9 into 10,000. We can write it 5.9 into 10 to the power 4 and so on. Now we take some example to understand it better. Express each of the following numbers in the standard form. First, 5985.3. We can write it 5.9853 into 1000. There are 3 zeros, so we write 5.9853 into 10 to the power 3. Second, 65,950 is equal to 6.595 into 10,000. There are 4 zeros after 1, so we can write it 6.595 into 10 to the power 4. Third, 3,430,000 is equal to 3.43 into 1 million. We can write it 3.43 into 10 to the power 6 because 6 zeros after 1. So we can write it in exponential form. Students, in my next lecture, I will explain exercise 13.1. Okay, have a nice day.